Now we are going to look at something called operator precedence. So you might have observed that we are having many operators, but if more than one of them are present in some expression, so for example 2 plus 3 into 4, then what is the order in which it is evaluated? Which means that is it that in this case we are going to do 2 plus 3 and then multiply the result 2 plus 3 5 into 4 it is 20, or we are going to firstly do this thing 4 into 3 12 and plus 2 14. So what is and as you can see that when you execute this you are going to have the answer 14. So we can see that there are a lot of operators, and then there has to be some rule, some logic of how they are given preference in order of computation. Similarly, let's say we have exponentiation operator 2 raised to the power 3 or whatever 2 exponentiation 3 and then multiplied by 4. Then are we going to do 2 raised to the power 3 and the result is multiplied with 4, or firstly we are going to do 3 into 4 and then 2 raised to the power that result 12? So what is the exact answer? So as we can see that somehow we have to have a precedence that okay, multiple operators are involved, then what is the order in which they are executed. Secondly, we'll see that if more than one operators are there in the same expression. So for example, let's say it is not exponentiation. Here, let's say it is simply multiplication. Then 2 into 3 into 4. Then whether this right side multiplication is done first or the left side multiplication is done first. That is called associativity. Like in which order we group the things. That is the second thing we'll look at. Apart from that, simply expressions, operators in an expression, rather than that we can also have something like this, that a is equal to 5 plus 3. Now intuitively it looks like, yeah, firstly we will do 5 plus 3, but then why we will do 5 plus 3 first? Equal to is also an operator, it is called assignment operator. Plus is also an operator, in this case it is addition operator. So why we are saying that this thing will be done or this done first, or this thing will be done first? So as we will see that precedence the precedence of plus is higher than that of precedence of assignment, and that's why firstly this thing is done and then we are going to do that assignment. So let's put everything into context, and then we are going to see that there is something called operator precedence. So this is the order in which things are going to be executed, which means that if we are having something like this or this, then first thing we are going to do is grouping, which means that if there is any place where parenthesis is there, this parents brackets is there, then first of all that is having the highest priority. Okay, and you can see that assignment sort of things is having the lowest priority, which means that everything you do and in the end you do the assignment. So now from this table it is somewhat becoming clear that how the expressions are being evaluated. In the same sense we'll see that since this multiplication and addition, we can see that while we are comparing multiplication and addition, then here it is clear that firstly multiplication has to be done and then the precedence of addition comes, which means that firstly this will be done and then whatever the result comes, that will be added. So this is what operator precedence is. Now we'll see that okay, so grouping is the first one. Now we'll go one by one among all of them. Post fix increment and post fix decrement, which means that something like a plus plus and let's say a minus minus, something like this. So let's say we have a variable a, let's say it is equal to 5. Okay, and let's have an expression which is something like a plus plus plus. So firstly let's take two variables. So let b is equal to let's say 10. Okay, and then we are doing a plus 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 b plus plus. Okay, and then let's print this value d. So will execute, then we'll see that 15 is coming. Okay, so we understand that this thing is evaluated and it is assigned, this expression is assigned a value of 5. This thing got evaluated and this got assigned a value of 10. Why? Because it is post increment. If it would have been plus plus a and plus plus b, then it would be 17. Why? Because this expression will give us 6 and this expression will give us 11, and 11 plus 6 will be 17. Okay, and the same thing, there can be decrement also, that is fine. But what if I do something like this, that no, there are not two variables, there is just one variable, then what is going to happen? You see, the answer is 13. So okay, we are saying that okay, 5 plus 5, it is 10, but then it is 13. So basically here what is happening is that a is increasing, and then after that the increased value is again increasing. So first time when it is increasing, 6 came, and then again the second time it incremented, it got 7. So 7 plus 6, that is 13. But the important question is, what happened here? Is this increment happened first or this increment happened first? You understand? So which of the increments happened first? In a similar fashion, if we do something like a plus plus, and here I also do a plus plus, then the answer is 11, but the 6, so one is 5 and another is 6, right? That is fine, but which one is 6? This expression is 6 or this expression is 6? So regarding that, this in bracket, what we are writing, that is right to left, which means that when there are multiple operators of the same kind, then there is a particular ordering in which it gets executed. So for example, if we have a simple expression, something like 5 plus 3 minus 4 or something like that, or let's say simply for that matter, let's have all the pluses, then what is the order in which it is summed? Is it the case that firstly 4 plus 3 summed to 7 and then 7 got added to 5, or it is the case that firstly 5 plus 3 got added and then we added 4 to the 8? So why this is important? Because in this sort of in these simple expressions it might not make sense, but in complicated expressions, knowing this, that in what order it is evaluated, is important. In this case the answer will be same, that is obvious, but still you should understand that how the addition is going to happen or subtraction is going to happen, or for that matter any other operator. The grouping is how happening. So in this case you will see that later it is written that addition and subtraction is there, they are having the same priority, which means that if you have this, okay, then this expression will be evaluated, but how it will be evaluated? That will be evaluated from left to right. So you can see that at some places it is written right to left. In that case the evaluation is from right to left. I will give you an example of that. But if at other places where it is not written, it is from left to right. So in this case, as you can see that in addition or subtraction, we have not written that thing, which means that by default it is left to right. Now left to right, which means that firstly 5 plus 3 is executed and then 4 is subtracted, rather than this 3 minus 4 minus 1 and then minus 1 is added to 5. That is not the case here. From left to right it is executing. However, let's say something like this, 2 raised to the power 3 raised to the power 2, let's say something like this. What do you think will be the answer? In this case it is not the case that it is left to right, it is right to left. So just you have to remember that what is happening. And in case of any confusion, if let's say if you are not remembering some some ordering or some precedence, then the best way to do is that if you want to, let's say, do this first, and you're not sure about the precedence, then simply put it in bracket, parenthesis, and that would be fine, because now you are getting the intended behavior without worrying about, okay, by default whether it will do firstly 2 raised to the power 3 and then do, so answers will be different, you understand. If I do something like this, then what is the answer? The answer is 512. Why? Because I did something 3 raised to the power 2 9. I got the answer 9. And then I did 2 raised to the power 9. 2 raised to the power whatever answer came. And 2 raised to the power 9 is 512. However, if something like this was there, that I did firstly this, right? Then it will be 2 raised to the power 3, which is 8. And then it is 8 square. Whatever the value came, we are squaring that. So now it will be 64. You see, 8 square. But my question is that if you and if you are having any confusion, that is fine, then just use the parents. But my question is that if you don't use parents, then what is the default behavior? As we can see here, in exponentiation, the grouping happens from right to left. This is called associativity, which means that firstly this thing will be done, and then this thing will be done, right? So, this thing will be done in the sense that whatever will be the answer from this thing. So 3 raised to the power 2 9, 3 raised to the power 2 9, and then 2 raised to the power whatever result, 2 raised to the power 9 will be the answer. So here, without giving brackets, you see that still 512 is the answer. So you have to remember that in some cases associativity from left to right, some cases from right to left. Again, if I convert that exponentiation to multiplication, now it will be from left to right, because you can see that multiplication you are having left to right. Okay, multiplication you are having left to right. Why it is not written, then by default it is left to right. I mentioned you, wherever right to left is there, I have specifically mentioned here. Now multiplication will be left to right, which means that in this case, firstly this thing will be evaluated, 2 into 3, and then that thing will be multiplied. The answer will be same, that is fine, but you should know that how it evaluates. See why that is important, because you can see that, let's say I have new variables, let's say x and y, okay, and okay, I'll come back to that after some time. There is something called chained assignment. So let's look at it. So let's say I do something like a is equal to b is equal to 5. That is the thing I am doing. Then what do you think will be a, and what do you think will be b? First of all, what will be the answer, and next why it will be the answer. So you see a and b are both are 5, but this is not a like mathematically if you see that a is equal to b is equal to 5, that 5 has happened, but b is equal to 5 is directly assigned, that is fine. But how we can say that a is 5? How a has come out to be 5? So actually what is happening is that a is being assigned this whole thing. You understand? This whole thing is an expression. So assignment also gives some value. And as what value it gives? Assignment gives the value which is the last value assigned. So the last value assigned here is 5. And that's why this whole assignment expression will give 5, and that's why that 5 is assigned to a. You understand? And how I have been able to group this, how I can say that this thing is happening, how I can say that, because it might be the case that let's say b was already defined by some value 10, then also it is 5, right? So why it is not the case that a is assigned 10, right? Why b is assigned 5? And because that is how the assignment operator works, as shown here also. It is saying that, see, assignment, again, like multiplication can be multiple multiplication. We can have the multiple multiplication symbols in the same expression. In a similar manner, we can have assignments, multiple assignments also, which is exactly the case here. And how to deal with this, that is exactly what it is written, that you have, if multiple assignments are there, then the associativity will be from right to left. And that's why firstly I did the right association, and then I did whatever answer came, then I did the previous association, left association. Okay, so the association will be coming from it. So if nothing is written, then why that answer is coming, that you can see from here. Okay, Now, as I told you that this thing is also an expression, which means that assignment is also an expression. In a similar manner, we can say that if, let's say, simply a is equal to 5 is there, okay, and I do something like this, then I can have something like this: x is equal to, and then I can have something like this: y is equal to. You understand? So what is happening is that whatever the value a plus plus is going to happen, I am doing an assignment, and this whole thing will be assigned. This whole thing is again an expression, and what is its value? Again, I told you, in assignment the value is the last value which is assigned. So in x, whatever is assigned, that will be the value of this whole expression. Okay, why I am doing this test? Because from this you can understand that when the simple expression this thing was written, let d is equal to a plus 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 a plus plus, when simple this thing was written, then whether this executed first or this executed first, just this is a complicated way of knowing that. Because now if I print x and y, now if I print x and y, then I can clearly see that what is going to be the value of these variables. So let's say simply, let's say this is x, and okay, that is fine, that is fine. So let's write a. So obviously what will be the a? A will be plain and simple. Since it is 5 and 2 times we have incremented, then obviously it is going to be 7. That is fine. But the interesting thing is that, see, x is 6 and y is 5. You see, x is 6, which means that this thing is basically executed after this thing. You understand? Which means that if and let's do the same thing here. I do minus minus. Let's say I do the plus plus and plus plus a. Okay. Then you see that this thing. You see, this thing is 7 and this thing is 6. Okay, so what is happening here? What is happening is that, okay, it was earlier 5. Firstly, this increment happened, the value is 6, and that's why the value was assigned to y. That 6 value was assigned to y. Okay, and then again it got incremented, and then we got, already a is 6, and then 6 plus 1 7, and since it is pre-increment, this whole expression is 7, and that's why that 7 is assigned 7 is assigned this side. Now you can understand that, okay, why this has happened, because I have done the grouping, and in grouping whatever the value we are going to have, that will be basically calculated based on the parenthesis which we are putting. So let's remove the parenthesis. And let's see. Now see, this is invalid syntax. You see. So here grouping is necessary. So you can see that always the syntax will not work. Sometimes you have to group in order to make the syntax work. However, in this case it is pretty fine, right? Or for example, if I would have done simply like something like this, this would be also fine. Okay, or something like this, which means that here it makes sense, because this expression in isolation can make sense. Here what was happening is that what was the problem in this case? The problem in this case, that if I don't have parenthesis, then I know that plus has a higher precedence than equal to. Then I have no way of knowing that what is happening here, why syntax error is happening. Because if I do something like this, then it does not make sense, because after that if I have a value, then how that value is this incremented value is going to be assigned to a value. See, in any assignment operator, the left hand side must be a variable. In this case, this thing is not a variable, but this thing should be executed first. Why? Because the precedence of plus is higher, and that's why this gives us a syntax error. Anyways, the idea is just to expose you to the fact that there is something called precedence, operator precedence, and in a simple manner you can just remember some of these things, and most of the things will be like intuitive. So you know that firstly grouping has to be there, and then I know that okay, if I have an expression like this, then obviously it makes sense to firstly before doing addition or for that matter here multiplication, whatever, it makes sense that firstly pre increment or post increment or even unary minus. So let's say minus, only minus a is there, then obviously these sort of things has to be done first, right, before doing this arithmetic operations. So that's why you can see that postfix and postfixed increment and post decrement both are done, and similarly post increment, pre-increment and pre-decrement both are done, and then unary negation, which I just mentioned. So obviously these things have to be done first, then we go to other things like multiplication, addition or exponentiation. Among them, what is the priority? Among them, the priority is that if I do something like 3 into 2, let's say plus here 2 into 3 plus 2, right, then firstly multiplication will be done and then addition will be done, right. However, don't think that in childhood what rule you remembered, that okay, firstly division is done, like Bodmas rule, something you remembered, right, that firstly division is done then multiplication. That is not the case here. You see that multiplication and division both have the same precedence, which means that if I have something like this here, the precedent and the precedent, they have the same precedence, then after they have the same precedence, then what is the, how we decide the order? The order we decide based on associativity. What is the associativity? Associativity will be left to right. Now left to right, which means that firstly this will be executed, and then whatever the result, that will be divided by 2. Why? Not because multiplication has a higher precedence, just because both have equal precedence, and the operation will be done, the grouping will be done from left to right, which means that if I would have done something like this or whatever, something like this, then also this would have executed first. So in this case multiplication would be second, division will be first. Why? Because multiplication and division both have same precedence, and among the same precedence we take the associativity rules, which will be here, that firstly you have to group this because left to right associativity is there. So firstly you have to do this, and then whatever is the result, 2 by 3, okay, this is 0.66, whatever the answer came, that value will be multiplied with this. So you can see that in this case the answer is 0.66 into 10, which is 6.66. Okay, even if this thing is multiplication is later. So there is no order in multiplication and division. Similarly in plus and minus also there is no particular order. Plus and minus, subtraction and addition have the same preference, which means that here also it will be done firstly the left side and then the right side, which means that even if it would, here plus is happening first, but here the plus will happen later, because associativity says that firstly you do this, perform this computation, and then you do this. Anyways, in this case the answer will be same, but you understand the point that how internally it is actually working. And a simple thing you have to say that yeah, addition subtraction have lower preference, above that the more preference is given to more precedence is given to multiplication and division, and exponentiation is having further more precedence, which means that if something like 2 exponentiation 3 and multiplication 10, if something is there, then preference is first given to exponentiation. It means that even if it would have been something like this, then firstly this would be done, wherever exponentiation is there, that will be done first. And you understand there can be multiple expressions like this. So for example 2 raised to the power 5 plus or minus 12 plus 3 or something like that. You understand? So what is going to happen? Firstly all the exponentiations are going to happen, okay, then all the multiplications, so which means that firstly this thing will be evaluated, this thing will be, so let's say here 2 would have been there, then this 2 raised to the power 10 would have been evaluated, and here 2 raised to the power 5 would have been evaluated, and then they will be replaced by their answers, meaning 2 raised to the power 10 will be there, then this is going to be how much, 1024, and then this 2 raised to the power 5 is going to be there, which means this will be replaced by 32, and then next set of rules will apply, that okay, exponentiation is done, now multiplication and subtraction, the more precedence will be given to multiplication, so this thing will be, and this will be a huge number anyways, so yeah, so whatever the computation that will be done here, and then that answer is being and again let's say somewhere here division is there, then what will be done first? So multiplication and division have the same precedence, but here firstly this thing will be done again, because we are telling that first, left to right. If it would have been something like this, then also firstly this would be done, and then this would be done, because that is how multiplication and then whatever the answer, then addition and subtraction, it is going to happen. So you can group it like in chunks, that firstly grouping will be done, and then pre-post unary things are there, so it's just remembering sort of thing you can say, and then exponentiation, and then division and remainder and multiplication all are having same precedence, and then addition and subtraction. Finally, if there is any comparison, then that is done, and then means comparison can be less than, greater than, or equality. So firstly non-equality sort of comparison is done first, and then equality or non-equality in the sense that greater than, less than, that sort of, and exact equality and exact non-equality, that is lower in the priority. And finally the assignment is done, and in the assignment you can have other things like plus equal to, minus equal to, we discussed that, right? So a plus equal to 5 means a is equal to a plus 5, right? So those sort of final assignment things will be later. After addition subtraction, these things will be happen, which means that if you are having something like let's say 2 is less than 10 plus 5, or let's say plus 2 is less than 10, less than let's say 35. So you see, or let's say it is greater than, whatever, let's say, then you see that all these are having same precedence, right? Then how the grouping is done? Again, the grouping is done from left to right. Why? Because if nothing is given, then it means that left to right, which means that here firstly this thing will be evaluated, and 2 is less than 10, yeah, 2 is less than 10, true. And here again I said that okay, so there is some other operator like and this thing will be invalid, because see, this thing is a value which is true, right? And true, and you see why it is true, because this thing is a value which is true, and if true is used at a place where comparison is there, then it is used as 0 or 1. You understand? So I am saying that if I say true is less than let's say 1, or let's say less than 2 for now, okay, then what I was saying is that generally there should be another number to compare, but if you put true or false at places where it should have a value in comparison, then true is treated as 1. So you see that here 1 is less than 2, it is true, right? And if you see, if I place 1, then it will become false, and if I do true less than equal to 1, then it is true. Why? You understand that here true is treated as 1, and that's why 1 is less than equal to 1 is true, but if I do exactly less than, then that will be false. Again same thing, if I use false, then false is less than 1, if false will be treated as 0, and that's why 0 is less than 1 will be true. But if I do less than 0, then it will be false, because 0 is not less than 0, but if I do 0 is less than equal to 0, then again it will be true. Okay, so unfortunately the example which I was trying to create here, that had this sort of situation where this thing turned out to be a boolean. So any comparison operator, right, any comparison operator, the evaluation, the final expression evaluation value will always give a boolean value. We'll see more of that later. There are other things you can do with that, which are called logical operators. You can do and or on the Boolean values. We'll come to that. But by now you might have understood that these operators will be used first, and then other things will be done. So I can do something like, even if I don't do bracket here, then 2 less than thing is equal to let's say 3 greater than 8. Okay, so what is happening? 3 greater than 8, 3 greater than 8, this is false, right? And this thing is, this side is true. So true, this side is evaluating to true and this side is evaluating to false, and in the end equality is happening. Why? Because just now we saw that first precedence will be given to less than and greater than, and then equality will be given, and that's why this thing will be false. But if I give here let's say both side true, so let's say I give, let's say 13. So 13 is greater than 8, that is true, and 2 is less than 10, that is also true, and true is equal to true, yeah, that is true, and that's why the answer will be true. Okay, so now you understood that how the precedence operators are used. There are some more operators which are not here, like logical operators. Just we will discuss that later, and then we are going to come back to it. So we'll discuss logical operators in the next video.